Welcome back to Science Modernizers. In today's video, we are going to see a question on mechanics from the Cameroon General Certificate of Education Board June 2022 session, specifically question 3. So as observed on our screen, we observe our partner, that's Objective Corporation, which is an academic partner to Science Modernizers, and basically they offer special competitive entrance examinations 2023. So generally in this group, they prepare you to go in for national competitive entrance examinations in Cameroon. So the program begins as seen on the flyer on the 15th of June 2023, and the centers are found at Carrefour Bilimada Dominion, ASOS, Hotel du Plateau, Mendong at Saint Achille. Basically, those are the centers which they have. So, in order to get more information and to acquire good and competent preparation to get into your professional schools in Cameroon, you can always get to Objective Corporation. They are made up of a quality staff, and they give quality preparation for national competitive entrance examinations. For more information, you can get to these contacts below. So let's get started with the problem statement. So the question here says, what is meant by the moment of a force? And state one condition necessary for the body to be in equilibrium on the plane. Figure 1 shows a uniform plank of weight 6 Newton and length A inclined at an angle theta. Calculate theta given that the system is in equilibrium, and this is the beam already shown in the question, and definitely we are asked to calculate the value of this angle theta. So let's get started to see a proposed solution to this problem. So we are going to begin with what is the moment of a force. So when we talk of the moment of a force, the moment of a force is simply the force acting on an object times the perpendicular distance from the line of action of the force. So the moment of a force is defined as the turning effect of the force about a pivot, and is a product of the force and the perpendicular distance d from the line of action of the force to the pivot. So that's basically the definition of the moment of a force. So if the distances are not given to you in a perpendicular or in an orthogonal manner, always try to resolve them in order to get the components of the perpendicular, so in order to get the components of the force. So the next question says we should state the conditions necessary for a body to be in equilibrium. So from the principle of moment, the conditions necessary for a body to be equilibrium is, the first, we need to know that the resultant moment on the system should be zero. So all the sum of the moments, be it clockwise or anti-clockwise, that is, the sum of the clockwise moment should be equal to the sum of the anti-clockwise, or in other words, the resultant moment in that system should be zero. That is the first condition to be met for a body to be at equilibrium. The next condition is the sum of all the forces on that system should give us zero. In other words, if the system is made up of forces on both components, that is on the y-axis and on the x-axis, then the forces along the x-axis should be equivalent. That is, if you take the sum of the right forces minus the sum of the left forces, then you should have zero. That's basically what this means. The vectorial sum of the forces on the system should give you zero. If you have vertical components, you take the upward forces minus the downward forces, and it should give you zero. And then we can see if these two conditions are met, then the body is in equilibrium. So the third part of the question stated that a system was given in which we assumed that the system is at equilibrium, and for us to and for the system to be at equilibrium, there is a certain value of theta for which that system should be at equilibrium, and this is the beam system displayed, in which we have the weight of the beam. The weight of this beam was given to be 6 Newton, and definitely this is a beam which is inclined at a given angle theta, but there is a property. We are going to consider this as a straight line, and the properties of a straight line is the gradient of straight lines measured from a given point is a constant. So we get that this angle theta is the same as this other angle theta, since they are measured from the same reference point and to the same other reference point from two lines which are basically parallel to each other. So from here we get that The weight of the beam is 6 newton, and we are asked to calculate the value of theta for which this system will be at equilibrium. So definitely we begin by resolving the forces. Now this is a pivot given to us, and on this pivot there is definitely going to be a reaction force R. The length of the beam was given in the question to be A, and this force of 4 newton was given in the question. So definitely, since this is the force, this is the 4 newton force, then we can have two components of this force. So the two components of the force will be the horizontal component and the vertical component. So the vertical component will be along the inclination of the plane, that is this force which we see given by 4 sine theta, and this is the resultant. So the resultant force here is 4 newton. So the direction of this other force will be in this other direction. So definitely the same thing shall occur with the weight. So the weight in general is 6 newton, and the vertical component will be given by 6 sine theta. If you have difficulties of seeing 6 sine theta, just assume this is like the hypotenuse of a possible triangle which can be formed, and if you project a line just along this point vertically downwards, you are going to realize this side of the right angle triangle is the opposite, and the side opposite to this definitely carries sine from SOHCAHTOA. And if you resolve the components from SOHCAHTOA, you are going to have these two components. And if we do same with the angle 60 degrees, we're also going to have 16. Since this force is 16 newton, we are definitely going to have 16 sine 60 and 16 cos 60. Now the distance from the end of this beam right up to this pivot is A divided by 4, and since the total length is A, then it means the length from the pivot right up to the other end will simply be A subtracted. You subtract this from A, which is going to give us 3A divided by 4. Now, in order for us to resolve the value of theta, we are going to use these two conditions. That is, the sum of the moments about the point should be 0, and that the sum of the resultant forces on the system should be 0. So on this plane, I'm basically going to use these inclined directions, and I'm going to consider my moments about the pivot. Since R is an unknown, and since R is an unknown and theta is an unknown, if I take moments about this point, I'm definitely going to cancel out this R. That is, it's not really going to complicate my equation, since I'm going to have just a single unknown, which is theta. But if I take moments in other points, then definitely I might have this arrow in my equations, which can give you more complex equations. So each time you are taking moments, always try your best to eliminate the maximum unknowns from the point which you are applying your moments. So definitely, if we proceed in order to get the value of theta, we are going to start by taking the sum of forces along a y direction. So here, the y direction is not actually the vertical plane, so it is defined here to be we are going to take it along this inclined section. That is, since this force is parallel to this force, which is parallel to this force, so it definitely tells us that the sum of the forces along this inclined plane will simply be we have R, which is above. R will be equal to 16 cos 60 plus, since R is an upward force, for the body to be at equilibrium, the sum of the upward forces will be equal to the sum of the downward forces. So it definitely means R will be equal to 16 cos 60 plus 6 sine theta plus 4 sine theta. So that is the first equation. And the second, we are going to take the moments about the pivot. So taking moments about this pivot, it definitely means the moment of R about the pivot will be 0, since there is no perpendicular distance which R has from this point, and the distance of R from the point of application of the force R is 0. So that moment will be 0. So we proceed and we identify the perpendicular component. So notice that this force is not perpendicular to this pivot. So the perpendicular force to this pivot will be 16 cos 60. So how then will 16 cos 60 behave? Is it a clockwise force or an anti-clockwise force? So following the reference as seen on the screen, The anti-clockwise force are forces which moves in a direction opposite to that of the clock. The way the clock rotates, just take the opposite direction. That's basically how the anti-clockwise forces move, and clockwise follows the direction of the clock. So if we look at this force is going to cause this beam to move in this direction. So which direction is this? We kindly see that it is an anti-clockwise force, and the perpendicular distance from of this force from the pivot is clearly a divided by 4. So definitely, let's identify if we have another anti-clockwise force with respect to this pivot. So definitely we see that 6 sine theta is going to cause this body to move in a clockwise manner, likewise 4 sine theta. So the only anti-clockwise force here is 16 cos 60, and from the principle of moment, for the sum of the moments in that system to be 0, then the sum of the anti-clockwise moment should be equal to the sum of the clockwise moment. So we definitely get that 16 cos 60 times 8 divided by 4, which is this force times this perpendicular distance, that's the only anti-clockwise force, should be equal to the sum of the clockwise moment. So this force 6 sine theta has a perpendicular distance of a divided by 4 from this pivot. Since this distance is a over 4, and from the pivot to the point of application of the weight, which is the center of the beam, is also a over 4, since we know that the distance from the center of the beam right up to one end will be a divided by 2, so it definitely tells us that this distance will be a divided by 4, and from there we get that 6 sine theta times a all over 4 plus 4 sine theta. 4 sine theta is found at this one end times the perpendicular distance, which is 3a divided by 4. So if we simplify that, 16 cos 60 is half, because 60 is half, and half times 16 gives us 8, and definitely 8 divided by 4 gives 2, and we have 6 sine theta. So if you simplify, we realize that the a's are common everywhere, so a will simplify. So here we get 3 all over 2 sine theta, and here this 4 simplifies and we get 3 sine theta. So if we simplify that expression, we get that 9 sine theta will be equal to 4, that is taking LCM here and cos multiplying by 2, from where sine theta will be equal to 4 over 9. So for us to get the value of theta, you simply take the inverse sine function on both sides. So definitely theta will be equal to sine inverse of 4 over 9, in which the numerical application gives us 26.39 degrees. So in general, for this system to be at equilibrium with these forces applied on the system, then the value of theta should be 26.39 degrees. So thank you very much for watching this video. Please do not forget to like, share and subscribe, and stay. For all those interested in going in for national competitive entrance examinations, you can always get to objective corporations. So science modernizers remains your best bet. So thank you very much for watching, and stay tuned to our channel. In the next videos, we are going to see some detailed explanations of mock examinations in Cameroon. So stay tuned on our channel as we see in the next video. So see you in the next video.